Here's our second part on graphing equations of lines. This is the standard form. And yes, the last video also said standard 18. This is standard 18 for real this time. So standard 18, the standard form of a line graphing. This is what standard form looks like. A times x plus b times y equals c. Things to remember about standard form. A will always be positive. A and B will always be not fractions. Both of them, if you're in a good standard form. And C will always be a number. It's called the constant. So while in slope-intercept form, you'll get some fractions in there. If it's in standard form, there will not be a fraction. If it's written this way. Alright, there's two ways to graph it. The first method is to convert it to slope-intercept, like we graphed in the last video, and then graph it. So here's our converting. We're just trying to get y by itself. 2x minus y equals 10. Let's move the x by subtracting 2x from both sides. That cancels out. We have negative y equals negative 2x plus 10. And the final thing to do would be to deal with that negative right there. So we can divide by negative 1 on both sides, which would cancel that negative and change the signs over on the right side. So instead of negative 2x, we'll have positive 2x. Instead of plus 10, we'll have minus 10. Alright, so now that I've converted, I can graph 2x minus 10. Remember from the last video, the slope of this line then is 2. The intercept is negative 10. Let's put our x's on here. We're going to go down to negative 10. One of the advantages to drawing your own axes instead of being given graph paper is that you can make it go down as far as you need it to for your graph. Alright, so let's plot this point first. Remember from the slope-intercept video, you do the intercept first. So there's my negative 10, and then you do the slope. The slope of 2 is the same as 2 over 1. Go up 2, and then right 1 every point. Up 2, right 1. Up 2, right 1. Up 2, right 1. Draw your line through your points. Let's do a different one. Okay, method 1 is you take this standard form and convert it. So you solve for y. Let's get that green line out of there. Subtract 3x from both sides. That's a 0. 4y equals negative 3x plus 8. I'm putting the x's in front just to copy that pattern of the slope-intercept form, just to keep it familiar. The last thing we have here is 4 times y. Let's undo that with division. Remember, everything gets divided on the right. So 3 divided by 4, we'll keep it as 3/4. 8 divided by 4, we need to say is 2. So let's graph this now. B, or the slope, or the y-intercept is 2. My m is negative 3/4. Let me draw my axis. Remember, plot the intercept first, plus 2, and then do the slope. Down 3, right 4. 1, 2, 3, 4. Or up 3, left 4. 1, 2, 3, 4. Connect your points. Okay, the next method, you don't have to solve the equation. You find the x and the y-intercept, and you put those on the graph and connect the points. What that requires, though, is you plug in zeros for the variables. And then you solve the one that's left over. So this one here, if I'm going to solve for x, I'll put a 0 in for y. So the x-intercept let's say 2 to x minus 0 equals 10. 2x equals 10. Divide by 2. My x-intercept is 5. To get the y-intercept, then you'll put a 0 in for x this time. We'll go 2 times 0 minus y equals 10. 2 times 0 is 0, so we'd have negative y equals 10. And then divide by negative 1 to deal with that negative on the y. Negative cancels. My y-intercept was negative 10, which, if you recall from the first example, was what we did before. Let's get a graph on here. That's not going to work for me. Need the space for the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5 for the x-intercept. So I'm going to use the colors. The y-intercept was negative 10. The x-intercept was positive 5. And you only need 2 points for a line, so once you have those 2 points, put your line through. That should look the same as what your method 1, example 1 looked like. Let's do the other one with finding intercepts. So x-intercept. We put 0 in for y. So we'll say 3 times x plus 4 times 0 equals 8. That's 0, so we'll say 3x equals 8. Divide by 3. X is 6 2/3. We'll have to approximate that. Let's find the y-intercept. Plug in a 0 for x. I'll go 3 times 0 plus 4y equals 8. 3 times 0 is 0, so I have 4y equals 8. Divide by 4. My y-intercept is 2. Let's get the axes on there. Remember, the vertical is y, the horizontal is x. I always do the y-intercept first. Let's put the 2 on there. And then the x will have to approximate a little bit. Oop, I used the wrong color. Y-intercept, we did blue. Okay. Y-intercept was 2, x-intercept was 1, 2, 3, 4, 5, 6, and a little bit more. You've got 2 points. Draw a line between them. That's a horrible line. 2 points. Draw a line between them. And so this is a good time to show where using the X and Y intercept method doesn't quite work out so well, because I had to, because I got a 2/3 there, I had to eyeball that and approximate where the 2/3 was, versus when we did this with slope intercept in method 1, we didn't have to approximate anything. It went straight through. Alright, so again, method 1, convert to slope intercept, and then graph. Method 2, find the X and Y intercepts, then draw the line between them. So it could potentially be less work. Oh, I just found my error. Did you notice that? This graph here did not look the same as that graph. So what I did wrong was that is not 6 2/3. That should be 2 2/3. Let's fix that. 1, 2 2/3. That looks a lot better. Alright, so that matches up with what we did over here. It was the same equation. 2x plus 3y was the same. So we should have gotten the same graph, which we did now. Okay, bye-bye.